Greetings, math fans. All right, so this is the first part of the statistics unit, and it's actually it takes about 3 days to do this unit just because there's so much information here, and I want to go through everything definitely in detail. All right, so really you have two note sheets for stats, and the first one is going to be just talking about different ways of measuring average. So anyway, let's just get started here. All right, so the first set of data that we have is 11 different numbers, okay, or 11 numbers. You can say different one, 11 numbers, and most of the time I'm going to give you these numbers in order. All right, and notice they are in order here. I don't always give you an order. In fact, I think one of the examples I have just to be able to create a way to summarize it, they're not in order. But most of the time I'm going to give you an order because I don't want you guys to make a mistake with summarizing the data. If it's not in order and you're missing something, that's not my goal, is to mess you guys up. My goal is really to have you guys be successful in the stats part, okay? So anyway, you got 9 pieces of data here in numerical order. The first thing is the mean, and you guys pretty much know what this is. You've seen this before. The mean is our arithmetic average of the set of values, okay? I don't like when it's called the mean. I think that whoever developed it should have come up with something a little more pleasant, like friendly, because mean just means it's like, man, it's mean. I'm just kidding. Okay, so it's arithmetic average of a set of values. So basically, you just add them all up, and so here it is, right? You add them all up here, and you divide by the total number, 11. Okay, and there's your answer, 30.27. Super easy. Okay, the median, you may not know what the median is. The median is basically the midpoint of the range of numbers. So in other words, they have to be in order from lowest to highest, and then it's the middle of that set, the physical middle of that data. All right. So in this case here, there are five numbers here. Okay, and then there are 5 numbers up to here, and then 5 numbers here. All right, and so then our median is 34. That's pretty much what it is. And here's the deal, math fans. If there's an even number of data points, so let's say instead of being 11, there was 12, there's no real middle. So then what you do is the median is the mean or the average of the two middle values. Okay, so just for example, let's just say the two middle numbers happen to be 34 and 35. Okay, then you would say, 34 plus 35 divided by 2. The average of those, so your median then would be 34.5. Okay, pretty easy. And we're going to use that in a little bit here, median. In fact, we're going to use it a lot. All right, and the last thing is the mode, and the mode is the value that occurs most frequently in the set of data. Okay, so in this case here, let's kind of clear some of the stuff out here. The mode is 40. You guys agree with that? Because 40 is the one that's repeated twice. And here's the deal. If there's more than one mode, then you list all the modes, and basically then you say it's multimodal. So we have kind of, just some words. If it's 2 modes, it's bimodal. If it's 3 modes, it's trimodal. 4, quadmodal. I mean, you don't really say trimodal maybe, but no more than that. Okay, but you say it's multimodal. Okay, so those are our 3 ways to measure, we say average, is mean, median, and mode. Okay, and now the Stemleaf Plot is basically a way to graphically summarize the data. Okay, and actually a way to order the data. I should almost really say order the data. So we can, again, I can read this here. This is a device for presenting numerical data in a graphical format. A basic stem and leaf plot contains 2 columns. Sometimes it's 3, depending on, like this second one here is 3 here. All right. The left column contains a stem, and the right column contains the leaves. A key is always included to basically define the meaning of the stem and leaves. So let's just kind of talk about what this means here. If you notice, first of all, the leaves are always single numbers. All single numbers? Oh, sorry. Okay, so they're always single numbers here. And the stem is going to be, it can be 1, 2, 3, 4. It can be double digits, triple digits, whatever. But usually the leaves are single digits, just like single leaves. And the stems can be anything. Okay, so this is actually pretty key. That's why I say key. But you need to have a key there. The key, so it's 1 line 2, basically means it's 1, and then here's your line, right? 1 line 2 means 12. So you need to tell me that, because otherwise I could say 1 line 2 is 1.2. I don't know what it means. All right. So if you don't have a key, I'm going to put a little star here. If you don't have a key, I will mark 1 point off for every problem that you don't use a key or have a key for a Stemleaf plot. Okay. All right. So anyway, that's a basic Stemleaf plot. This next one, the second one I have here, is a little bit different because it kind of splits it up to male and female. Okay. So again, your stem is right here. This is your stem. And then your leaves are the things from the male and the numbers from the female. Okay, it just happens as they split up a little more specific. And then the second one, or the third one here, is actually one that is used as well. I definitely would know this one. Okay, I would know them all. But this is, people see the L and the H. L just means low numbers, and H means high numbers. So if you notice, the low numbers are, it says 1, 3, 4. So low numbers are 0, actually I'll say 0 to 4. And high numbers are 5 through 9. Okay, so you can even see, like here's 1, 3, 4, 6, 6, 8, 0, 1, 1, 7, 9. You can see the numbers are low and high. Okay, so again, it kind of just breaks it up a little bit more, as opposed to saying all zeros and putting 1, 3, 4, 6, 6, 8. That's a lot. So they kind of split up, and let's show you the low numbers and let's show you the high numbers. Okay, so again, 3 different kinds of stem and leaf plots. This is probably the most simplistic one, the first one. The second one breaks it up, male, female. You could have, I don't know, AM, PM, whatever. Okay, and then the third one actually splits up to low and high. Okay, so that's pretty good. Our next thing here is frequency distribution and cumulative frequency distribution. So frequency distributions are often presented as lists, okay, ordered by quantity, showing the number of times each value appears. Cumulative frequency is a running total of that current frequency. So again, it just shows you how frequent something happens, how often something happens. Okay, so a tally just helps with the count. The reason that we do a tally, sometimes kids are like, well, that's kind of dumb. Why are we doing a tally? Well, if you're taking data, if you're out at a stream and you're taking data of how many different fish you see, whatever, and you're actually taking it, you're marking it down. Oh, here's one, here's another one, and you're doing a tally mark. Okay, and then frequency, you just add up the tally marks. And cumulative frequency is just you keep adding it. Like, for example, 2 just goes here, and then 2 plus 2 gives you 4, and then plus another 4 gives you 8, and then a plus another 3 gives you 11. Okay, this is really important too. There's usually between 4 and 10 equal class intervals, depending on the number of pieces of data. So if you have a lot of data, you're probably going to have more class intervals. Okay, but you're only going to have a maximum of 10. And the reason we have a maximum of 10 is because otherwise you start breaking it up into too much. Okay, if I have 20 class intervals, then it's almost complicated to look at the data. And if I have too little, then everything's clumped together and it really doesn't split up the data at all. Okay, so that's why we have between 4 and class. So when I ask you guys to create a frequency distribution and cumulative frequency distribution chart, you need to do a couple things. First of all, here's your class interval. So you need to have, in this case here, I have 4 class intervals. So it needs to be between, again, 4 and 10. And then you move on from there. Now, real quickly, see this 10 and 19? Kids sometimes do this. They do between 10 and 20, and 20 and 30, and 30 and 40. Well, what's wrong with this? Well, because 20's counted twice, and so is 30, and so is 40, right? So this, you don't want to have this, because if I was looking for ages, and you're 20 years old, where do you tally it? Do you tally it in the one from 10 to 20 or the 20 to 30? So if you do what I just did here, that you have 19, and then 20, and 29, and 30, and 39, and 40, and 40. There's no overlap, so you don't have to worry about, you don't have to worry about the overlap, and you can tell exactly where the piece of data is supposed to go. Okay, so that is that chart. Let's keep going here. We have our little friendly histogram, and histogram actually is a graphical display of tabulated frequencies. So we use the frequencies to say, well, 10 to 18. So really it's based off the last example that I did, 10 to 18, or 10 to 19, 20 to 29, 30 to 39, and 40 to 49. All right, and so if you look at if you would go back, but it goes up to 2, and this one up to 2, and then this one up to 4, and this one up to 3. Okay, so histogram is very, very simple. There's no gap, no spacing in between these. You just have to make sure you label everything, and these need to be here, and this needs to be here, and that's it. But I'll tell you the key word. I even wrote it here. The key word for a histogram is frequency. How often does it occur? That's what this part is here, guys. Okay, that's the frequency. It occurs 1 time, 2 times, 3 times, or 4 times. Okay, so here a couple just a quick thing here. An example of a histogram would be maybe the height of a student or distance to planets. So how frequency, right? You could say, so how often does a student how often does a person 6'2" or 6'1" or 5'11", 5'10" distance to planet? You can kind of list the different planets. It doesn't have to be in our solar system, but you can list the planets that are maybe 5 million miles away to 10 million miles away, and 10 million miles away to 13 million miles away, right? And you can list it that way as as this number down here. All right, IQ all math teachers. Okay, that could be a frequency. Which ones have between 10 and 20 for an IQ. All right, and 20, well, hopefully it's higher than that, I hope. All right, so basically any data with numbers or quantity, you can use a histogram. Okay, again, frequency is the key word. That is so key here, frequency. Okay, not histogram examples are anything like with words. Okay, right, obviously a breed of dog, certainly can't put breed of dog here, or color chalk, or manufacturer cars. It doesn't make sense. Okay, so it's all about frequency. Okay, so now we're going to go to modified box and whisker plots. This is actually the most significant part of the lesson. It's basically a convenient way of graphically depicting groups of numerical data through a 5-number summary, which we'll talk about right now. The smallest observation, that's called your sample minimum. So let me highlight a couple of these things here. So we have your minimum. That's the first number summary. Then we have our lower quartile, we say it's Q1. Then we have our median, it's Q2. And then we have our upper quartile, which is Q3. And then we have the largest observation, which we call our maximum. Okay, and that is, those are our 5 numbers. A box plot may also indicate which observations, if any, might be considered something called outliers. Let me give you an example of what an outlier is. Okay, if we have our class, and our class has got, everyone's kind of like between 5 feet tall and 6'3". All right, but we've got Jimbo the Giant in class, and he is on the basketball team, and he is 6'11". So he would be an outlier because most of the people are between that 5 to 6'3", and all of a sudden you got this one person who's just gigantic, and he's 6'11", and he would be something we call an outlier. Okay, that's actually a pretty important word. We're going to use that a lot. So that's an outlier. There are 2 types of outliers. There's a mild outlier and an extreme outlier. We're actually going to focus on the mild outlier. We'll talk about the extreme outliers in a little bit, but mild, when you see the word mild outlier or just outlier, that is really, like I said, just a regular outlier. Okay. The larger the whisker or the box section, the larger the whisker or the box section, the larger the range. This is a hugely key word here. The larger the range for that quartile. All right. So what I want you to understand is there is, as far as the amount of data here, there is 25%. If there is no outliers, and even if there were, let's say there's an outlier, which I'm not going to put one there, but 25% of the data is here, including, so it's this this whisker. 25% is here in this box. 25% is here in this box. And 25% is in this whisker, or if there's any outlier, then it includes that. Okay, so there's always 25% of the data in each of those. Okay, so a really bad thing to tell me is if I say, well, let me clear this out here. If I said, so out of all these, out of this modified box and whisker plot, which one has the most data? And you went, let's see, I think this one has the most data. Boo! Doesn't have the most data. It has the widest range of data than the other spots, but it doesn't have any more data because they all have 25% of the data. Okay, so it's really easy to look at this guy and go, oh, well, that doesn't have a lot of data at all. Yes, it does. And how could that possibly be? How could it be so small? Well, here's a way I can describe it. Let's say we have 32 kids in our class, and there are 8 kids who are 6'3". Exactly 6'3". It just happens that there are 8 kids that are 6'3". Okay, that means 1/4 of the kids are 6'3". That's why this would be the tiniest little piece here, because and again, if this was 6'3" right here, okay, so that would make that a small range because it's just 6'3". And then the next range between 6 foot and 6'3" is a little bit bigger range, and then between 5'4" and 6 feet, that's a big range, and then between 4'10" and 5'4", that's a decent sized range too. Okay, but it's all about the range. Histogram is frequency, modified box and whisker plot, range. Okay, very, very important. So let's take a look at, let me erase this because I want to talk a little bit about this now. Okay. If I look at the 5-number summary for this box and whisker plot, okay, modified, I call it a modified box whisker, that's what it is. The minimum value is 12. So look at this. Here's the minimum value. That's about 12. Okay. And a couple things. Minimum value is not always the end of the whisker. Not always. Okay. Q1 is 21. So this is Q1 right here. So minimum and Q1. Okay, median is 34. So here it is, 34, and this is the median. And Q3 is 40. So Q3, and there it is 40. And the maximum value, again, maximum value is not always the end of a whisker. It may be an outlier, but that is 41. Okay, so that's kind of what the box and whisker plot looks like, and then we're going to, we'll create a modified box and whisker plot in a little bit. An outlier on the bottom here, an outlier, none shown for this one, data is that is past the length of the whisker. So if that whisker was out, let's say there's a data point here, and that's past the length of the whisker, we call this an outlier. Okay? Interquartile range. That's kind of a fancy word. Interquartile range. Definitely gets you mashed potatoes because, seriously, think about it. You go home and you're like, hey, Mom, I learned about interquartile range. She's just going to be like, oh my God, get more mashed potatoes for this kid. You are so smart. Okay? Anyway, interquartile range is literally the difference between Q1 and Q3. So it's Q1, it's actually Q3 minus Q1. It's a big minus a small. Okay, so in this case here, it's the 40 minus the 21. Okay, so in this case here, it's 19. That's the IQR, interquartile range. Okay? If there are no outliers, this is a nice little question for you. If there are no outliers, what percent of the data is contained between each of the 5 summer numbers? Well, because I just told you that. If there are no outliers, what percent of the data is contained between each one? Well, of course, how much data is contained here, and here, and here, and here? Each one has 25%. Okay? Sweet. All right. Let's keep going here. This is definitely a long lesson here, so if you need to take a break, yeah, I'll write 25% here. 25. If you need to take a break, then just pause me and come back to me later. Okay? All right. So here's some more detailed instruction on how to create a modified box and whisker plot. The first thing you're going to do is you're going to create a stem and leaf plot because you got to order the data. Okay, if the data is all kind of in crazy, order, you got to put it in order because you got to be able to find the median, right? You got to find the physical middle of the data. All right, so that's the first thing you're going to do is create a stem and leaf plot. The second thing you're going to do is you're going to find the median. Okay, and again, it's pretty easy. It's the physical middle of the data. If there's 2 pieces of data, then you take the average of those 2, and that's your median. Okay, and then the third step is to find the quartile 1 and quartile 3. Basically, it's the medians of the data above and below the original median. So it's like the middle of the upper part and the middle of the lower part. And I even said this can kind of get a little tricky. So I basically have 4 scenarios here to help you figure out what the median and the Q1 and Q3 are. All right. So the first scenario here, math fans, it's if you look at the data, I have 5 pieces of data. Okay. Well, this is really easy, right? Do you guys agree that this guy right here is the median? Pretty easy. Now I need to look at the upper values and the lower values of to find the Q1 and Q3. So here's the deal. I have 2 pieces of data here, 2 on this side. Okay, so what I'm going to do is I need to find the median of those. Well, just like a regular median, if there's an even number of pieces of data, I just average the middle ones, which in this case is just 1 and 2, and that's my Q1. Okay, and so if I do that, it's 1 plus 2, so basically 1 plus 2 over 2. So it's 3 over 2, which is 1.5. Okay, and I do the same thing with the 4 and the 5 for the Q3. So that's going to be 4 plus 5 is 9 over 2 is 4.5. Okay? Pretty easy. All right, scenario 2. The median is, now it's the average of these two, which like I'll just draw my line over here. It's 3.5, right? 3 plus 4 divided by 2, 3.5. And here's the deal. When you have 2 median or 2 numbers like this to average, this one, I got rid of the number. I got rid of the 3. Okay. This one, where you have 2 of them, you actually don't get rid of it. You split it. So then the upper number belongs with the upper range, and the lower number belongs with the lower range. Okay. Does that make sense? So basically, in this one, I'm going to use 1, 2, and 3 as my numbers. Okay. So let me circle that now. I'm going to use 1, 2, and 3 as my numbers, and I use 4, 5, and 6 as my numbers. Okay, but again, that's only if you have 2 numbers. If you have 1, that's it. You just delete it. So what is the median of 1, 2, and 3? Of course, it's the middle number, so it's 2. And what's the median of 4, 5, and 6? Of course, the middle number, which is 5. Okay. All right. So let's go to scenario 3. Scenario 3 is I have 1 through 7. The middle number is 4. I'm going to real quickly here, because I need to show you this, the way to figure out the middle number. If you've got 50 pieces of data, it's kind of hard to count the middle one. So what you do to figure out the middle of the data is you basically take the number of pieces of data. So I'm going to do this on the side here. I'm going to do it in green, my favorite color. There are 7 pieces of data, and I know there's one middle. So what I'm going to do is I'm going to say 7 plus 1 is 8 divided by 2 is 4. So 4 is my median. Okay, so that's if there's a single number in the middle. You always add 1 to it, and you divide by 2. And if you ever forget that, just write 3 numbers out there: 1, 2, and 3. What's the middle number? Okay, well, it's the second one. So what do? You add 1 to 3, you get 4. 4 divided by 2 is 2, the second number. Okay, that's the way to remember it. All right, so let's look at scenario 4. Scenario 4 is I have 8 numbers, so it's an even number. That means there's no middle number. So what I do with that is I say basically 8 divided by 2 is 4, and I choose 4 and 5. Just a good way to remember that. Okay, again, if you're not sure and you have 1, 2, 3, 4 numbers, right, I would just say 4 divided by 2 is 2. So 2 and 3 would be my 2 numbers. Okay, just a way to remember it. So if you have, so let me just kind of give you an example here. I can kind of do this a little bit on the top here. If you have 50 numbers, you know there's not really a middle for that one because it's even. So you say 50 divided by 2 is 25, so you're going to take 25 and 26, those 2 numbers. Pretty easy. If there is 71 numbers, then there is a physical middle, so I add 1 to it. I get 72. And I divide that by, I divide it by 2, and I get 36. So 36 is my 36 number is my middle position. Okay, just a little helpful hint there. Okay, let's go back to this guy here though. We said our median for this guy is 4. Oh, sorry. I was on this one. Okay, 4 and 5. So 4 and 5, and then the average of those 4.5, and then remember I split it in half because I'm using 1, 2, 3, 4, and 5, 6, 7, 8. So the median for 1, 2, 3, 4 is, again, these average of this 2 and the 3 which is 2.5, and the average of the 6 and the 7 is 6.5. Okay? Very important. We spent a little bit of time on this because you really need to know how to find the Q1, Q3, and the median based on different types of data. Very, very important. Okay. So and what I just described now, math fans, this is what I just described. Okay. So if you want to look over it again, I'm not going to read it over again. What I literally just talked about is that summary. All right. Number 4, after you do that, after you find the median and the Q1 and the Q3, then you're going to find the interquartile range. Again, super easy. Q3 minus Q1. That's all you do. Okay? Number 5, you're going to find the length of the whisker. And this is the deal here, math fans. The maximum whisker length is 1.5 times IQR. 1.5. That's really, really important. 1.5 times IQR. Okay? So we'll do an example in a little bit, but that's what you do here. Okay, the end of a whisker is always a data point. And notice what I wrote here. I wrote, kids forget this. Okay? End of a whisker is always a data point. So you don't extend the whisker all the way out to the end. If there's wherever the data point is, the highest data point that's within the whisker, that is going to be the end of a whisker. Okay, and again, I'll show you an example in a little bit here, but super important. And I even said, if a data point is past the maximum length of a whisker, then it's considered a mild outlier. All right, and the data point is plotted. So if it's past the whisker, then you plot a point past the whisker. And I even said, remember, the whisker may not fully extend even with an outlier. Okay, and again, we'll talk about that. We'll do a couple examples. I said, note here, we'll refer to mild outliers just as outliers. An extreme outlier is 3 times the IQR. So a good example is, I'm sure most of you have heard of Yao Meng. He's enormous guy from China. He used to play basketball. He was like 7'7". He is probably an extreme outlier. Okay, if you guys got Jimbo the Giant and he's 6'11", that's kind of an outlier. Maybe an extreme one, but that's definitely an outlier. But all of a sudden you jump up another 8 inches, that is huge. So Yao Meng would definitely be an extreme outlier, and then you do 3 times IQR. We're not going to worry about that. We're just going to deal with mild outliers or just outliers. Okay. So I even said here there may be no outliers or several outliers. All depends on the data. Okay. Like if you have a normal class with no really tall people, no really short people, no outliers. Okay. If you got a bunch of kids in the basketball team that are all 6'9", 6'10" in the class, then you got a bunch of outliers. Okay. So a couple things. Note, a modified box and whisker plot differs from a normal box and whisker plot. I keep saying modified box and whisker plot. A normal box plot's whiskers extend all the way to the smallest and largest data points, no matter how far they are. Okay, so those whiskers just go out to no matter what. A modified one only extends in what we just learned. It only goes out to a certain amount, that 1.5 times IQR. Okay, and also this is another important thing too. The smallest value for a whisker is 0. Okay, it doesn't make sense to, if I'm having whiskers for my modified box and whisker plot, and I say, well, okay, it represents heights of people, and the whisker goes down to like negative 2 feet. I'd be like, well, who's even going to be down to negative 2 feet? Okay, so the maximum or the smallest value for a whisker is 0. Okay, so let's take a look at this one nice little friendly modified box and whisker plot with no outliers and just see what it's all about. Remember, each quartile has 25% of the data. Very, very important. The range of the lower values is larger than the range of the upper, because this is big, and this is small, and this is small. So the range, once again, range is important. The range of the lower is larger than the range of the upper. Okay? And then the median is greater than the mean. So let's talk about, let me erase this here again. So this is the median. All right, this line right here. And so if I ask you which was greater, the mean or the median, what happens is this range of data, because it's kind of it's spread out so far, and this is spread out so far, and this is tight, and this is tight, this spread out data is actually going to bring the mean down. So the mean might be somewhere like here. But again, the median is the physical middle of all the data, so that would be the red line, and the mean is going to be pulled down to the left because that data is spread out and it's pulling it down. Okay? All right, so let's keep going here. I have a nice little friendly example for you guys. All right, our first example here, math fans, the data is not in order. This is probably the only time I'm not going to give you the data in order because I want you to create the stem and leaf plot using the data. Okay, so here's the deal. Remember I said the leaves need to be single digits, and the stem it can be a double digit, triple, single. It could be a single digit as well. If it was like 15 or 16, right? Then the stem is 1 and the leaf is 5. All right. So I look at this one. I'm like, oh, I got 246 and 215 and 208. So I'm going to make it. It's of course going to be a 2-digit number. And if I look, the lowest number that I have here is, I'm going to kind of mark things a little bit now, is going to be 208. I see 208 and 208. And that's it. It's only the 200. So I'm going to say my stem is going to be 20, and I see a 21. I see a 22. There's a 220, so 22. I'm going to see a 23, so there's 235. So I see a 23. 242 over there, so 24. And I don't see 25. Actually, this seems to be my highest number here. It skips actually to 282, so 2 and 8. That is going to be I kind of purposely made this stem and leaf just so it would fit on the page. I mean, you wouldn't necessarily know that it's going to be, you're only going to have 6 numbers or 6 stems, but just so it would fit on the page, I put that on there. All right. So the leaves. Let me erase this top part here. And the leaves are going to be the single digits. So what I'm going to do is kind of way you order it here is I'm going to do, this is 215 and 215, and I'm going to write it out then. Or sorry, I'm not doing 215. Should be doing 205 and 208. Okay, there we go. 208 and 208. So I'm going to put an 8 here and an 8 here, and then I'm going to cross it off when I use it because I don't want to reuse that data or get confused. Okay, so the next one is going to be, let's see, I see a 215. Keep going down here. I see a 212. I see another 215, and that's the only 21 something. So I'm going to do 212, 215, and 215. But notice I'm putting in order. You got to put in order. That's how you find the median. Okay, so that's out of here. That's out of here, and that's out of here. Okay, now the 220s. So I'm going to do 220, 228. 224 and 227. So that's 220, 224, 227, 228. Okay, cool. Let's cross those off. These and that. Okay, cool. Now 230s. There's 231, 231, and 237. So we got, and I think I'm missing one here. And 235 right here. Okay, good. So 231, and then 231s, and then a 235, and then a 237. Okay, cool. So we can cross those off. And then I've got 240. So the 240s, 242 here, 243, 246. Okay, so we got 242, 243, and 246, and I can cross those off, and I really have just one number left, is 282, so 282. Okay, this little, where I wrote key down here, I will not have that for you. Okay, you have to write your own key. You're going to make your own stem and your own leaf plot, very simple, and then you got to give me a key. If you don't give me a key, then I take 1 point off, and you don't want that. That's terrible. Okay, so key would be 20 with /8 is 208. Again, that could be 2 or it could be 20.8. A lot of different things, but that's what this means. Okay, pretty easy. All right, the mean is, again, the average. And so we're going to, I'm not even going to give you, let me erase all this stuff now here with the numbers. Okay. This is a non-calculator chapter, so you should really know how to do mean anyway, but I'm not going to give you anything crazy where you have to calculate it out like that. But it does turn out to be 3904. That's the sum of those divided by 17. So there's 17 pieces of data. So my mean is 229.65. Okay. The median is, again, so we're going to count now. Now I know there's 17 pieces of data because I counted them, okay? There's 17 pieces of data, so what is my middle term? Remember I told you what to do? You do 17 plus 1 is 18, divided by 2 is 9. So the ninth term is my middle term. So if I count 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is my middle term. It's 228. 228. Okay? Pretty easy. Now, let's just figure out the mode. The mode is one that occurs the most often. And if you notice, 208 occurs twice, 215 occurs twice, and 231 occurs twice. So you're going to list them all. 208, 215, and 231. So this is trimodal. Okay? All right, so let's keep going here. So the 5-number summary, so I'm going to label this, the 5-number summary. This is my minimum. This is Q1. This is my median. This is Q3. And this is my max. Okay, so the minimum is really easy. That's just 208. And the maximum is really easy. That's 282. And we already figured out the median is 228. Okay. Now what you need to figure out is Q1. So what I'm going to do is, remember it's the middle of the numbers here. So of the top section is Q1. So again, I'm going to ignore that 8, right? If it was 2 numbers, I would cut in half, but now I'm going to ignore it. So if you think, how many numbers do I have here? Well, again, I can count, and that's okay. But think about it. If I had 17 numbers, and if I have 17 numbers, there's going to be, and I add 1 to that. 17 plus 1 is 18 divided by 2 is 9, right? That's how we got the 9th one. That means there are going to be 8 numbers below it and 8 numbers above it. Everybody agree with that? So if there are 8 numbers below it, let me write this. There are 8 numbers below it. That means, so if I count this, right? 1, 2, you can count them just to check, right? There are 8 numbers. Okay, that means, remember I told you what to do? 8 divided by 2 is 4. So you're going to count the 4th and the 5th term. That's how you do it. It's pretty easy. So if I count the 4th and 5th term, 1, 2, 3, 4, this is the 4th and the 5th term. That's pretty nice. Happens to be the same number. So the average of 215 and 215 is 215. Pretty sweet. Okay, so let's do the 4th and the 5th term on the bottom as well, because of course, there are 8 numbers on the bottom. So 1, 2, 3, 4, and 5. So it's 237 and 242. So 237 plus 242 divided by 2. It's the average of those two numbers, and it gives us 239.5. Okay? So that's our 5-number summary. Very, very easy. Okay, let's keep going here. Interquartile range, again, very simple. Interquartile range is just going to be Q3 minus Q1. So it's going to be 239.5 minus 215. Okay, and that's going to give us 24.5. Okay, very cool. Now, the maximum whisker length, remember what you do, it's 24.5 times, again, which is our IQR. So 24.5 times 1.5. Always 1.5 as far as we're concerned now, because it's a mild outlier, or we call it just an outlier. Remember, if it was an extreme outlier, it would be times 3, but we're not using extreme outliers. Okay? So multiply that by 1.5, and I get 36.75. So what I'm going to do is I just want to actually cursor back to, here, this BoxWhisker Plot right here, the one that we just looked at. So what I'm going to do is, I just figured out that is the maximum whisker length that we got, and that number was 36.75. So the maximum length this whisker can be is 36.75, and the maximum length this whisker can be, I don't have enough room here, is also 36.75. That's the maximum it can be. The reason I say that's the maximum is because, remember, it has to be a data point. If there's not a data point at 36.75, then it's going to be shorter, but it's never going to be any longer. Okay? All right, so let's go back down to here. All right, so I'm going to take, here, let's go back to, so we can see our values here. We're going to do Q1 minus 36.75 because I want to see how low it's going to go to the left. And so Q1 minus 36.75 is 178.25. That's as low as it'll go to the left. And then to the right is Q3 plus 36.75. And that's going to be 276.25. Okay? So that's the maximum to the right. Again, these are maximum whisker lengths. Maximum. Very, very important. Okay? All right, so let us draw our picture now. Okay? I'm going to have to cursor down here, so you have to kind of remember what our minimum and maximum and Q1 and Q3. So the first thing I'm going to do is I'm going to draw a number line here. So if you guys can sketch a nice little number line. Okay, and then the lowest part of this the lowest part of the whisker was 178.25, so I'm just going to go down to 180. I'm going to go up by tens. 190, 200, 210, 220, 230. Hey, it's the dentist's favorite time. Oh, sorry. Get it? 230? Okay. 240, 250, 260, 270, 280, 290, and we'll go up to 300. Okay? All right. So the first thing I want to do is I want to draw my box. So you're basically going to draw Q1, median, and Q3. So Q1, if you look back at our notes here, Q1 was 215. So at 215, we'll do this in a different color. So 215, we're right here. And then median is 228, so right here is 228. And then Q3 was 239.5, so almost 240. And then we connect these together. There we go. And it's nice when you label it. So this is Q1, this is the median, and this is Q3. Okay? So that's good. Now we got to deal with our whiskers. So I want to go look back at the data here, math fans. Do you guys agree that our minimum point is 208? All right, so does 208, you look at this now right here, is 208 within the whisker length? It sure is. The lowest value is 178, so of course 208 fits in there. So what you're going to do is you're going to go down to 208 and you're going to start the whisker there. Remember I told you the end of a whisker has to be a data point. I cannot stress it enough. Biggest mistake that kids make. Okay, the end of a whisker has to be a data point. So that you would love to extend that whisker all the way down to 178.25. You'd like to put it all the way down to the left over here. Okay, but you're not because there's no data there. So you're going to go to where the data point goes down to, which happens to be 208. Okay, now let's go the other way. So the maximum whisker length is 282. And you're looking at this and going, oh, geez, look at that, 282. That's past the whisker. What does that mean? It means it's an outlier. It's past the whisker length. So you plot the 282, just plot it as a point. 282 is right here, and we're going to call it an outlier. It's nice to label things. Always label things. And so let's go to the next point. See if that's an outlier. The next one is 246. Oh, we're good. 246 is certainly less than 276. So at 246, which is right about here you're going to draw your whisker. Okay, and again, I know you'd love to extend that whisker farther out here, okay, but there's no data point there. So why would you extend it out when there's no data point to extend it to? Okay, so hopefully that makes sense to you guys. Okay, so anyway, that's the deal with that. Okay, so let's erase that little green spot there, and we're good to go. So this, math fans, is the answer to your problem. Modify box and whisker plot. Now I want to show you on your graphing calculator. Even though you're not allowed to use your graphing calculator, I think it's like good just to see what it looks like. So with your graphing calculator, let's pull up a graphing calculator here. Got it all set up here. Ah, there it is. Okay, good. Okay, so let's clear this out of here. And what you want to do is, first of all, I want to hit the stat button. Okay, I gotta lower this calculator a little bit. Okay, so I kind of adjusted the calculator here a little bit, so hopefully it fits in the screen. So what we're going to do, math fans, is we're going to actually use the data that we just typed in, because I want you guys to see how it's going to give us the exact same thing on the graphing calculator as it did doing it by hand. Okay, so the first thing you want to do is you want to hit stat, and you want to hit 5. Stat 5 is setup editor, and hit enter, and it'll say done. Okay, that kind of resets everything with your statistics. It's kind of a nice little feature. If you ever something's kind of goofy and you want to reset everything, that's what you do. So let's hit stat again, and let's hit edit. Now it's going to bring up a list L1, L2, L3. Let's just say, because I want to show you a couple things. Let's say I have a couple of numbers in here already. What you can do is I can cursor to each one of these numbers. I can either hit clear and type a number in, or I can just type a number in. So I can change it to 6, or I can just go up to here and say that's 9, hit enter. Okay, or I can go up to the top if I want to clear the whole list. Kind of nice. I can hit the top, and I can hit clear for the whole top and hit enter, and it clears everything. Okay, one more quick thing. Let's just say we have again some numbers in here, and I want to delete a number. So let's say I go up to, I'm like, oh, I didn't want to type in this 5. As opposed to just hitting clear, because clear just doesn't just let you type another number in. If I hit delete, it actually deletes the 5 and it moves everything up. Okay, now let's say you go to the top here and you accidentally hit delete, which you can delete columns. But watch, if I hit delete instead of clear, and you're like, we don't have L1, it's gone, and you cursor over and it's not there anymore, and you start to panic. And what I told you, the nice thing to do is you go to stat 5. Setup editor, hit enter, and let's go back to stat edit, and ta-da! L1's back again. So it didn't even delete the data. Okay, it just deleted the column from view, and you bring it back again. All right, so let me go back again on top and hit clear, and go ahead and type in the data now. So, and it doesn't matter the order because calculator is pretty smart, but since I have it in order, I might as well just type it in. So just again, be careful typing the data in. So we got 208. And you can fast forward to this if you're faster than me. I just have to go a little bit slower with this graphing calculator on the computer. 212, 215, 215, 220, 224. 227, 228, 231, 231, 235, 237, 242, 243, 246, 282. So we know we had 17 pieces of data that we typed in, all right, because we're now on 18. That's just kind of a good sign. Again, it doesn't hurt to cursor up here and just to double check, make sure you got all triple digit numbers here that you kind of typed in correctly, okay? All right, so that looks good. All right, so now what we're going to do is we are going to hit second y equals, so this guy right here, second y equals, which is stat plot, and you're going to turn your plots, or actually you just hit enter, because you're going to basically turn on. See how it's highlighted off? So now it's flashing on, you're going to hit enter to turn it on. And you're going to go down here, and you are going to choose. There's lots of different things to choose from, but you're going to see this one here. These two look like box and whisker plots. One's got the 2 dots, and one doesn't have any dots. Well, the ones with the dots are the modified box and whisker plots, because those are where it shows the outliers, and just the box and whisker plots is basically the whiskers. It has no the whiskers just go all the way out to the ends of the highest data and lowest data point. Okay, but we're going to choose the fourth one here, so this guy right here, and hit enter, and everyone should, everything should stay the same here. The last thing we're going to do is we're going to hit zoom, and we're going to do zoom 9. Okay, you don't see it on this calculator. Yours actually you see up to 9, just it doesn't show it on this one. Hit zoom 9, which is zoom stat. Watch. What? There it is. It's exactly what we came up with. Okay, here you can see the whiskers here. You see your outlier. Now the cool thing is you can even hit the trace button. Watch, hit the trace button. And there's the X min. That's the minimum value. If we cursor over, we see Q1 as 215, which is exactly what we got. Cursor over, see the median, 228. Cursor over, Q3, 239.5. And the maximum of the whisker length is 246, which we found is 246, our data point. And then the actual maximum value is 282. Pretty cool. It really is pretty cool. So your calculator will do all that work. And again, I kind of summarized that in the, I summarized this below here for you guys to look at. Okay, so you can redo it again, but it's kind of cool. Shows you all the modified box and whisker plot. All right, so it's kind of I know it's a long video, so you guys hopefully you're taking a break here every once in a while, sitting down and having a water or eating some popcorn or something. Okay, number 2. Let me adjust this thing here again. Okay, good. Now we're good. All right. So number 2 is just another set of data, and again, this is nicely in order for you. And so we're going to kind of go a little quickly through this because it's pretty straightforward now what we're doing here. Okay, but we'll, I won't explain as much, but we'll keep going here. All right, let's go. All right, so I'm going to fill this in. My stem is, again, you don't have to, just because you have start with a 3 doesn't mean you have to do a 4, a 5, a 6. Think of it this way. If you didn't have a stem, if you had no leaves, why would you even draw a stem, right? You're gonna, it's like, that's kind of a sad looking tree. All right, so I'm gonna put a 3 here, and then a 5, and then a 6, and a 7, 8, 9, 10, and then there's no 11 or 12, so I'm gonna put a 1, 3 here. Okay, that's my stem, and then my leaves are going to be the single digits. So I'm going to kind of put it quickly here. So this is 5 and 2, 0 and 5, 0, 3, 5, 4, 6, 7, 7, 8, 8, 9, and then 1, 3, 5, 5, 5, 7. And then 1, 0, it'll be 1, 5, 8, and 9, and 1, 3, and 0. And then my key, I'm going to say 3/5 equals 35. Okay, that's your key. Again, I'm not going to provide that for you, so you need to make sure that you provide it. Okay? All right, very, very important. Okay, so the first thing I'm going to do is I'm going to find the mean. Again, there's no calculator, but I'm just going to do it here. It's if I add all those numbers up, I get 2,158 over, and there are 25 numbers. So my mean is 86.32. Okay, my median is the physical middle. So there are 25 pieces of data. I just kind of said that on the bottom there. So if 25, remember what you do, 25 plus 1 is 26, divided by 2 is 13. So 13, that is my middle number. So if I count, I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is the middle number right there. Okay? And so I can write that in there. So the median is 88. Cool. And the mode is the one that occurs the most often, which actually is 95. Okay. Very simple, right? Not bad, not bad. So I'm going to ask you guys to do everything with this chart now. We're going to do a frequency distribution. Remember, this is something, again, I'm not going to tell you. I'm just telling you now. It's 4 and 10 equal intervals, right? If there's a lot of data, then you want to do maybe more intervals. If there's less data, then you do less intervals, but always between 4 and 10. It's usually the norm, okay? So what I'm going to do is looking at the data, kind of scanning the data here a little bit. I got starts like 35, I got it up to 130. So yours can be different than mine, it doesn't matter, but if I do from 30 and I do 20, I go up by 20s. That should be good for me. So I'm going to do, in this case here, 31 to 50, 51 to 70, 71 to 90, 91 to 110, and 111 to 130. That encompasses everything. Barely gets the 130 in there, but it encompasses everything. It's actually pretty good, and it's 5 class intervals. That's pretty good. Notice I didn't go 30 to 50 and 50 to 70 because you don't want to repeat numbers. Okay? And then what you're going to do is you're going to do a tally. I just can't fit everything on my, well, I can kind of fit on the screen, part of it. But the tallies, you just count the number between 31 and 50, and there's only 1. And the 51 to 70, there are 4. And 71 and 90, there are 9. Okay, and 91 to 110, there are 10 of those. And 111 to 130 is only one of those. So the frequency, your little baby brother can do this one, right? Frequency, you just count the tally marks. So this is 1, this is 4, this is 9, this is 10, and this is 1. Cumulative frequency, again, super easy. Think about when's the only time a cumulative frequency is going to be equal to the frequency? It's for the first one, because the cumulative frequency is 1. And then you go up from there. So 1 plus 4 is 5, 5 plus 9 is 14, 14 plus 10 is 24, and 24 plus 1 is 25. And again, that should be 25 because there are 25 pieces of data. Okay, so that is your frequency distribution. Now what we're going to do is, of course, frequency is the main thing with a histogram. It's a measure of frequency. So let's draw a nice little friendly chart. So can anybody tell me what this little line I drew is? Somebody said it's a heartbeat, which is only 1, which is not a healthy thing. But really what this is, and we're not necessarily using it here, but let's say I started my numbers at 300. You're going to make a tick mark for every 3, up to 300. You're going to go, oh, this actually skips those numbers, and then you start with the number you want. Okay, so anyway, we can do that, and this is 30, and this is 50, and this is 70, and this is 90, 110, and 130. Okay? And then basically on this, the y-axis, we're just going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's kind of labeled here, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, cool. So let me use a different color here to make it more exciting. So from 30 to 50, really 31 to 50, there's only 1. So we're going to go up 1 here. And then this next one's going to go up to 4. And the next one's going to go up to 9. The next one's going to go up to 10. And the next one is going to go down to 1. There you go. Hey, there's your histogram. Very exciting. Now, if you want to be all nice and decorative, you can color it. You know, I can do that and do that. It's very nice. do that. Whoa, fancy. That one, I only have 4 colors. So we can do swirly marks in there. Okay, that's cool. Specialized histogram, pretty easy, right? Cool. Okay, so let's measure of frequency. All right, so now we get on to the modified box and whisker plot. Okay, so it's got to be a 5-number summary. So we already have some of our stuff here, right? We already have let's label this minimum, and this is maximum, and this is median, and this is going to be Q1, and this is going to be Q3. All right, cool. So minimum is like super easy, 35. Maximum is super easy, 130. Okay, 130. Okay, and of course we already calculated our median, which was 88. Cool. So let's go back up to our data now, and we need to find our Q1. Okay, so I got our nice Stemleaf plot, and remember there are 13 was the middle, so you should know there are 12 before it. So, and there's only one data point, so we're not using that 8, so we're going to cross this guy out here. And we're going to use 12, there's 12 in the middle. So remember what you're going to do? You say, oh, it's 12 divided by 2 is 6, because there's 2 middle points, so you're going to use 6 and 7. The 6th and the 7th of the top, and the 6th and 7th of the bottom. So if I do that, 1, 2, 3, 4, 5, 6, and 7, so we're going to use these two. And the other way is 6 and 7. 1, 2, 3, 4, 5, 6, and 7. So we're going to use those two. All right, and it's the average of those. So it's basically 73 and 75, and the average of that is 74. And 95 and 97, so 96 is going to be this is Q1 and Q3. Okay, so we can label that in there. Lots of things to draw in here. Okay, so let's do that. What do we say? Q1 was 74, and Q3 is 96. Okay, cool. So interquartile range, Q3 minus Q1. So that's basically 96 minus 74, which is 22. Okay, so now to find the maximum whisker length, first of all, we got to do our IQR times 1.5. Don't forget that, man fans. IQR times 1.5. So 22 times 1.5 gives us 33. That's the number. That's basically the maximum length of the whisker to the left or the right. So that means we're going to say Q1 minus 33 to go to the left, and that gives us 41. And then Q3 plus 33, that's going to go to the right, so that's going to give us 129. Okay, again, it's a maximum. You got to understand, maximum whisker length. Doesn't guarantee you that's what the length is going to be, but it's the maximum it can be. Okay, so let us draw the box and whisker plot now. Oh yeah. So I'm going to kind of sketch this nicely down here. And we're going to start out with 30 here. Go up by tens, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130. Okay, that's good. 130 is pretty good. That's as far as it goes out. Okay, so what we're going to do is you always want to sketch Q1, median, and Q3 first, okay, because that's your box. All right, so let's do that. Q1 is 74, so 74 is about right there. And median's 88, so about right there. and Q3 is 96. So 96 is right there. Okay. There we go. There's the box. So let's label it Q1, median, and Q3. Cool. All right, so now you got to kind of take a look at the data points. I'm not going to keep scrolling up there because this computer is getting a little slow with all my writing I've done here. The minimum value is 35. All right, so if you look, this guy right here, it's 41. That's the maximum it can go down, so that means that 35 is an outlier. So you're going to plot 35. You're going to label this an outlier. Okay? The next lowest value is 52. 52 is within range. It's certainly greater than 41. So 52 is our next point. So we're going to graph 52, and we're going to draw the whisker. Okay? Remember, the end of a whisker is always a data point. So it can go all the way down to 41, but there's nothing at 41, so the next lowest one is 52, and that's where you draw your whisker. Okay? Now let's look on the other side. Okay, the maximum value was 130. That's a little past this 129, so it's an outlier. So outlier. Okay? And then what's the next one? The next notch down is 109, which is definitely within 129. So we're going to plot 109. And we're going to draw a whisker. There you go. Okay? So you see our two outliers. You see the maximum whisker, the whisker length for these. Again, those are all data points. Okay? And we're done. That's our box and whisker plot, modified box and whisker plot. So that's pretty cool. So just to kind of show you a little bit, if you compare that, if I can cursor up here a little bit, notice how the the whisker here on the left is a little bit longer, and that's because probably the range of the upper data is a little bit more, right? But remember, how much data is in the whisker part on the left? 25%, this box 25%, this box 25%, and this box, including that outlier, is 25%. Okay, so that is that's kind of our last main example with actually with data. So now let's just talk a little bit about. And again, it's a long video; it's literally over an hour. So hopefully you can take a little break here every once in a while. Okay, but let's talk about number 3 now. So let's cursor down here. Okay, so let's look at a few more modified box and whisker plots. In this example, it says, which is greater, the mean or the median, and why? So I'm just going to highlight this here. Right, this is our median, of course. And again, each of these, this whisker, this box here, this box here, and this box, and this whisker here, all have 25% of the data. Okay? So, which one's greater? So here's the deal. Since this range right over here, I'm going to put this in blue. So this range right here is so big, right, of positive, of greater numbers greater than the median, that's pulling all the data to the right as far as finding the mean. So the mean is going to be somewhere over here because of that big range pulling it over. So you're going to say, which is greater? You're going to say, in this case here, the mean is greater. Mean is greater. And the reason is the range of the data is greater above the median and basically what that does is it pulls the mean higher. So pulls the mean higher. Okay, I'll tell you, man, this is the key word here, guys. You got to use that word. If I ask you something about mean or median, and you're talking about the median, you better start talking about the range. If you don't talk about the range, I'm going to mark it wrong. Because you certainly can't say, oh, there's more data to the right. There isn't any more data. The data is just more spread out. The range, the range is greater, or you can say it's more spread out. Something about the range. Okay? Why are the whiskers so short? Well, you can say the range of the lowest and highest data points are very narrow. Okay, so that's the answer. The range, oh, did I use that word again? The range, interesting. The range of the lowest and highest data points is very narrow. That's why the whiskers are short. Okay, but I'm telling you, man, I like this baby here too. The range, huge. Don't forget that. Okay, all right. Let's go down to the next one here. Number 4. It says which is greater than the mean or the median. So again, this guy right here is our median. Okay, and what is, of course, what is this part right here? What's it doing? This is huge, huge range, and so that's pulling it down. So our median is, our mean is going to be, so again, this is our median, or sorry, mean, and the red was our median. Okay, so that big range that I just circled on the left, that's pulling the mean down. So in this case here, which is greater, you're going to say the median is greater. And the range of the lowest data points, oh, look at I use that word again, the range of the lowest data points is large. And those data points bring the mean down. So, and those low data points bring down the mean. Okay, and here's again, why is the left whisker so long? Well, what word do you think you're going to be using here? It has such a wide range of data points that are low. Okay, pretty straightforward here. Okay, let's keep going. Number 5, give a real-life example when a histogram would be better for summarizing data than a modified box and whisker plot. So basically, and we kind of even talked about this before, guys, any example that shows frequency. So any example that shows frequency. So any example that shows frequency. So if I said something like, number of A plus pluses or F minus minuses, brutal. Okay, age range, it could be, I could ask for the age of all the different kids in the class, and that could be, how frequent, the frequency could be, okay, who's 15, who's 16, who's 17, it could be ages. It all depends on how you use it as well. Okay, but it's a frequency, how often it occurs. Okay, give a real life example, so number 6, give a real life example when a modified box and whisker plot would be better. Basically, when you need to look at a range. So look at ranges. All right, so if there's a lot of data points, and I guess an example could be like scores on the final. Because there could be so many that you can get, and when I say scores, I mean like percentages. Because there are so many different percentages. You certainly wouldn't put that into a histogram as a percent, because you would say what, 10%? I mean, unless you did a range of that would be okay. But if I did individual, or if I want to look at, hey, what is the middle of the class, doing in this test? Then again, you're looking at the range, because then you're looking at the median. Okay, so that's probably where it would be best. When you're looking at, like I said, the range of some data. Okay, so as opposed to frequency. So again, the key word here is for histogram is frequency, and the keyword for modified box and whisker plot are ranges. Okay? All right, cool. We're almost done there, math fans. Whew, long lesson. Whoo, doggy. All right. Sketching a modified box and whisker plot given a histogram. So this is just kind of like some examples that I found on the web here of some histograms, and let's try and make a rough sketch of the box and whisker plot. So the first thing I'm going to do is I'm going to sketch just a normal box here. Okay, and well, what's going on here? I would say more of the data is over here. Do you guys agree with that? So it's kind of to the right a little bit. Okay, so the middle of the data might be something over here. So I would say this is going to be moved over a little bit to that side. And then, I don't know really about these here. The important thing for this guy here is that you draw this correctly. I would say drawing that median correctly. Okay, I don't really know too much about the whiskers or how wide the graph is or anything, so kind of something like that looks pretty good. Okay, so let's take a look at the next one. We actually say this is a normal curve, a bell curve, and I would say this, if I would sketch this, what do you think? I would say it's like right smack dab in the middle, and it is. So draw right in the middle. And what about the whiskers? Do you guys agree? I would say the whiskers are actually, just because remember it's got to have 25% of the data. So I would say 25% of the data is here, and 25% of the data is here. So this range, don't you guys agree this range is actually pretty big to get 25% of the data? And this range here is pretty big to get 25% of the data. So I would say my whiskers would be longer. Okay, so really the important thing here is, again, this thing needs to be in the middle, and this whisker are longer. Okay, that's cool. What about the next one? Well, it's kind of similar to that top one, except it's like kind of squished together. So I would actually say this box is going to be kind of a smaller box then, not as wide. Certainly in the middle, because I would say it's about in the middle. Okay, but once again, this is 25% of the data here, and this is 25% of the data here, and 25% of the data here. So again, those whiskers are probably a little bit longer, but the whole thing itself is shorter. It was not as wide. Okay, so again, I think I would highlight that this is definitely in the middle. Actually, the whole box is smaller, and these are a little bit longer again. Okay, I think that looks pretty good. Okay, so we got one more here. This we're going to learn later on in this chapter, but this is actually called, it's skewed to the right. Okay, so it's actually pulled, some of that data is being kind of pulled to the right of this histogram. So if I draw this is kind of spread out here a little bit. Let's draw a nice box, and I would say that most of the data is probably right about here. That's like the middle of it. Okay, and so we can kind of go over it on this side a little bit. That's most of our data is over there. And then I would say, again, this is 25% of our data here. 25% of our data is here. And then another 25%. This is actually pretty small, so that's there. And then another 25. I mean, this is not necessarily super accurate, but another 25% is here. And you might say, well, gee, this has more data than this. Well, okay, kind of close. But what's going on is this is like, these are smaller values. These are like spread out. So this is going to be a nice long whisker, okay? As opposed to this one is actually pretty short because it has a short amount of data here, right? It's still the same amount, but not as spread out. The range is less. Okay, so that is, again, to highlight stuff, I would say the median is a little bit more to the left. This has a nice big whisker here and a nice short whisker on the left. That's what would be a good description for that histogram using a box and whisker plot. All right, so this is a very long video, about an hour and 20 minutes. But hopefully, like I said, we took 3 days to do this, and hopefully you guys are good to go with the stuff. A lot of stuff here, but this is actually pretty significant stuff. It's all is gonna be on the test that we're gonna have, and certainly on the final exam. So hopefully you guys are working on the worksheet now and understanding how to do everything. All right, that's it, math fans. Have an outstanding day. Adios. Goodbye.